Imagine waking up one morning to a world where gravity, the invisible force that has shaped every moment of your life, has simply vanished, not weakened, not reversed, but switched off entirely, as if someone had flicked a cosmic light switch. You sit up in bed, rub your eyes, and before you can even swing your legs over the side, you're already floating. Your blanket, your pillow, your phone, all drifting gently upward as if the room itself has become a slow-motion snow globe. It sounds like science fiction, but let's take this thought experiment seriously. What would actually happen if gravity everywhere on Earth suddenly turned off? To answer that, we need to understand what gravity really is. Most people think of gravity as the thing that keeps us stuck to the ground, but it's much more than that. Gravity is the fundamental force that holds the universe together. It keeps the planets in orbit around the sun, the moon circling the Earth, and even the air we breathe pressed against the surface of our planet. Without gravity, the very structure of the cosmos would unravel. But let's focus on Earth for now. What would you experience in those first few seconds, minutes, and hours after gravity's sudden disappearance? First, let's clarify the rules of our scenario. We're not talking about gravity being turned off just for you, or just in your room, or even just on Earth. We're talking about gravity vanishing everywhere. All at once, the force that pulls every atom toward every other atom is gone. The laws of physics as we know them have been rewritten in an instant. This is not just a local glitch, it's a universal reset. And the consequences are both fascinating and terrifying. The first thing you'd notice is that you're no longer anchored to the ground. Your body, your furniture, your house, everything that was once held down by gravity would begin to drift. But it wouldn't be a sudden, explosive launch into the sky. Instead, you'd feel a gentle, almost dreamlike sensation of weightlessness. You might push off the bed and find yourself floating toward the ceiling, bumping into the light fixture, laughing or screaming in disbelief. The air itself, no longer held close to the Earth, would begin to expand and rise, carrying with it dust, moisture, and even insects. The world would quickly become a chaotic, swirling cloud of objects, people, and debris. But the real chaos would begin outside. Cars, trees, buildings, everything not bolted down would start to lift off the ground. Streets would become rivers of floating vehicles, their tires spinning uselessly in the air. Trees would uproot, their roots dangling like tentacles as they drifted upward. Houses would come apart, their roofs and walls separating and floating away like pieces of a giant disassembled puzzle. The landscape would dissolve into a three-dimensional jumble of objects, all moving in slow, unpredictable directions. And then there's the atmosphere. Gravity is what keeps our atmosphere wrapped tightly around the planet. Without it, the air would begin to escape into space, like water leaking from a punctured balloon. At first, you might not notice much difference. The air would still be there, and you'd still be able to breathe. But within minutes, the pressure would start to drop. The sky would darken as the atmosphere thinned, and the stars would become visible even in the middle of the day. Breathing would become more difficult, and you'd feel lightheaded, as if you'd suddenly been transported to the top of Mount Everest. Meanwhile, the oceans would be in turmoil. Gravity is what keeps the water in the seas and lakes pulled toward the center of the Earth. Without it, the water would begin to rise, forming massive floating blobs that drifted away from the surface. Ships and boats would be carried along with them, their hulls no longer slicing through the waves but tumbling through the air. Fish and other sea creatures would find themselves trapped in these floating spheres of water, their world turned inside out. But the most dramatic effects would be felt on a planetary scale. The Earth itself is held together by gravity. The rock, soil, and even the molten core are all pulled toward the center, creating the solid sphere we call home. Without gravity, the planet would begin to come apart. The crust would crack and separate, the mantle would expand, and the core would lose its cohesion. The Earth would slowly disintegrate, its pieces drifting away into space like the fragments of a shattered egg. And what about you? In the first few minutes, you'd be floating inside your house, struggling to breathe as the air thinned. You might try to grab onto something, anything to keep yourself from drifting away. But without gravity, there's nothing to hold you down. If you managed to get outside, you'd see a sky filled with floating debris, swirling clouds of dust and water, and the distant shapes of buildings and trees tumbling through the air. The world would be unrecognizable, a chaotic three-dimensional storm of objects and people. But the real danger would come from the loss of the atmosphere. As the air escaped into space, the pressure would drop to near zero. Your blood would begin to boil not from heat but from the lack of pressure. You'd lose consciousness within seconds, and death would follow soon after. The Earth, once a vibrant living planet, would become a lifeless, drifting cloud of rock, water, and debris. It's a grim scenario, but it's also a powerful reminder of just how important gravity is. We take it for granted, but without it, life as we know it would be impossible. Gravity is the silent architect of our world, shaping everything from the smallest pebble to the largest galaxy. Its absence would be catastrophic, but its presence is what makes our existence possible. So the next time you drop your keys or trip over a step, remember gravity isn't just a nuisance, it's the force that holds your world together. And if it ever disappeared, you wouldn't believe what happens next. But let's not stop at the immediate chaos. To truly appreciate the role gravity plays, we need to dig deeper beyond the first few minutes, beyond the initial shock, and into the fundamental ways gravity shapes not just our daily lives, but the very fabric of reality. Because when gravity vanishes, it's not just the world that falls apart, the rules of the universe themselves begin to unravel. Let's rewind for a moment. Imagine you're still floating in your home, the air thinning, the world outside dissolving into a surreal ballet of drifting objects. You might wonder, why does gravity exist in the first place? What is this force that, when removed, causes such instant and total chaos? For centuries, gravity was a mystery. Isaac Newton famously described it as a force that pulls every mass toward every other mass, an invisible hand that keeps the planets in their orbits and the apple falling from the tree. But Newton never explained how gravity worked, only that it did. It wasn't until Albert Einstein came along that we began to understand gravity on a deeper level. In his general theory of relativity, Einstein showed that gravity isn't really a force at all, but a warping of space and time itself. Massive objects like the Earth bend the fabric of space-time, and everything else, apples, people, even light, follows the curves and dips created by that bending. In this view, gravity is geometry. It's the shape of the universe dictating how everything moves and interacts. So if gravity suddenly turned off, it wouldn't just be a matter of objects floating away. The very shape of space and time would change. The orbits of the planets, the paths of the stars, the structure of galaxies, all would be thrown into chaos. The solar system, held together by the sun's gravity, would instantly fly apart. The planets, including Earth, would shoot off in straight lines, no longer tethered to their parent star. The moon would leave us behind, and the tides, driven by the moon's gravitational pull, would cease. The night sky would become a graveyard of wandering worlds, each on its own lonely trajectory through the cosmos. But let's zoom back in to the scale of everyday life. Without gravity, the concept of up and down would lose all meaning. Our bodies, evolved over millions of years to function in a gravitational field, would be utterly unprepared. Our sense of balance, our muscles, our bones, all rely on gravity. Astronauts who spend months in microgravity aboard the International Space Station experience muscle atrophy and bone loss, even with rigorous exercise. In a world with no gravity at all, these effects would be immediate and severe. Your body would begin to weaken, your bones would start to lose density, and your heart would struggle to pump blood in a world where down no longer exists. And what about the things we take for granted? Water, for example, behaves very differently without gravity. In space, water forms floating spheres, clinging to surfaces and drifting aimlessly. On Earth, gravity pulls water into rivers, lakes, and oceans, drives the water cycle, and allows us to drink from a glass. Without gravity, water would become a hazard, floating blobs that could drown you if you inhaled them, droplets that would never fall to the ground, rain that would never reach the soil. Plants, which rely on gravity to guide their roots downward and their stems upward, would be lost. Seeds would sprout in all directions, roots and shoots tangled in a confused mass. Even fire would behave differently. On Earth, hot air rises and cool air sinks, creating the familiar flickering flame. Without gravity, there's no convection, no rising heat. Flames would become spherical, burning less efficiently, producing more smoke and less light. Cooking, heating, even staying warm would become a challenge. But perhaps the most profound change would be psychological. Humans are creatures of gravity. Our entire sense of self, our orientation, our movement, our perception of space is built around the constant pull of the Earth beneath our feet. In a world without gravity, we would be disoriented, anxious, and afraid. The simple act of moving from one place to another would become a struggle. There would be no way to walk, no way to run, no way to jump. Every action would send you drifting, spinning, tumbling through the air. The world would become a three-dimensional maze with no floor, no ceiling, no walls, just endless disorienting space. And yet, even in this chaos, the human mind would try to adapt. We are, after all, remarkably resilient. Astronauts learn to navigate in microgravity, using handholds and footholds, learning to move with gentle pushes and careful planning. In a world without gravity, we might develop new ways of living, floating homes, tethered workspaces, new forms of transportation. But these adaptations would be short-lived, because the loss of gravity would quickly make the planet uninhabitable. Let's not forget the other forces at play. Gravity is the weakest of the four fundamental forces, but it's the only one that acts over vast distances and on all forms of matter. The electromagnetic force holds atoms and molecules together, the strong force binds the nucleus, and the weak force governs radioactive decay. Without gravity, the other forces would still operate, but their effects would be limited to the microscopic world. The large-scale structure of the universe, the galaxies, stars, planets, would dissolve. And what about time? Einstein showed that gravity affects the passage of time. Clocks run slower in stronger gravitational fields, a phenomenon known as time dilation. Without gravity, time itself would flow differently. The subtle differences in the passage of time between the surface of the Earth and the top of a mountain would vanish. The universe would become a more uniform but also a more lifeless place. So as you float in your home watching the world come apart, you're witnessing not just the end of life as we know it, but the unraveling of reality itself. Gravity is not just a force, it's the glue that holds the universe together. Its absence would be the ultimate catastrophe, a reminder of just how fragile our existence really is. Let's take a step back and consider the cosmic perspective. If gravity were to vanish, not just on Earth, but everywhere in the universe, the consequences would be even more profound than what we've already described. The universe as we know it is a tapestry woven together by gravity's invisible threads. Galaxies, those majestic spirals and ellipses scattered across the cosmos, are held together by the mutual gravitational attraction of billions of stars. Without gravity, every star in every galaxy would begin to drift apart, each one following a straight path into the infinite darkness. The beautiful structures we see through telescopes, spiral arms, glowing cores, star clusters, would unravel, dissolving into a featureless sea of isolated suns. But it doesn't stop there. Gravity is also responsible for the birth and death of stars. Stars form when clouds of gas and dust collapse under their own gravity, igniting nuclear fusion in their cores. Without gravity, these clouds would never collapse. There would be no new stars, no new planets, no new solar systems. The process that has created every star in the night sky, every planet, every moon, would come to a halt. The universe would become a static, unchanging place, devoid of the dynamic processes that have shaped it for billions of years. And what about black holes? Those enigmatic objects where gravity is so strong that not even light can escape. If gravity were to disappear, black holes would cease to exist in an instant. The matter that once formed their event horizons would explode outward, releasing unimaginable amounts of energy. The centers of galaxies, often home to supermassive black holes, would erupt in cataclysmic bursts, sending shockwaves of matter and radiation across the cosmos. The very concept of a black hole, a region of space where gravity reigns supreme, would become meaningless. Let's return to Earth, or what's left of it. As the planet disintegrates, the pieces that once made up our world would scatter into space. The oceans, now free from gravity's pull, would form vast, drifting clouds of water vapor and ice. The atmosphere, already escaping, would be swept away by the solar wind, leaving behind a barren, airless wasteland. The rocks and soil, no longer bound together, would break apart, forming a diffuse cloud of debris. Even the molten core, once held at the center by gravity's relentless pull, would expand and cool, losing its structure and energy. But the effects wouldn't be limited to the physical world. The disappearance of gravity would have profound implications for life itself. Every living thing on Earth, from the smallest microbe to the largest whale, has evolved in a world shaped by gravity. Our cells, our organs, our entire physiology are adapted to the constant pull of the Earth. Without gravity, the delicate balance that sustains life would be destroyed. Blood would no longer flow properly. Organs would shift and malfunction, and the processes that keep us alive would break down. Even if you could somehow survive the loss of air and the chaos of a disintegrating planet, your body would quickly succumb to the absence of gravity. And yet, as catastrophic as this scenario is, it's also a powerful illustration of the interconnectedness of the universe. Gravity is not just a force that keeps us grounded, it's the architect of everything we see and experience. It shapes the orbits of planets, the structure of galaxies, the flow of time itself. Its influence extends from the smallest grain of sand to the largest supercluster of galaxies. Without it, the universe would be a vastly different and far less interesting place. But let's not lose hope just yet. The fact that gravity exists, that it operates with such precision and consistency, is one of the great wonders of the universe. Scientists have spent centuries trying to understand its mysteries, from Newton's apple to Einstein's equations to the search for gravitational waves. Each discovery has brought us closer to understanding the true nature of reality, and each has revealed new layers of complexity and beauty. Consider, for example, the recent detection of gravitational waves, ripples in the fabric of space-time caused by the collision of massive objects like black holes and neutron stars. These waves, predicted by Einstein a century ago, were finally observed in 2015, opening a new window into the universe. They are a testament to the power and reach of gravity, a force that can send signals across billions of light years, carrying information about the most violent events in the cosmos. Without gravity, there would be no gravitational waves, no cosmic symphony echoing through the void. And what about the future? Gravity is not just a relic of the past, it's a key to our destiny. The fate of the universe itself depends on the balance between gravity and the other forces at work. Will the universe expand forever, or will gravity eventually halt the expansion and pull everything back together in a big crunch? These are questions that scientists are still trying to answer, and they remind us that gravity is not just a background feature of reality, it's an active participant in the ongoing story of the cosmos. So as you imagine a world without gravity, remember that its presence is a gift. It's the reason we have planets, stars, galaxies, and life itself. It's the force that allows us to stand, to walk, to dream. Its absence would be catastrophic, but its existence is a source of wonder and inspiration. And yet, even as we marvel at gravity's power, we must also recognize its limitations. Gravity is incredibly weak compared to the other fundamental forces. A small magnet can lift a paperclip against the entire gravitational pull of the Earth. And yet, because gravity acts on all matter and over infinite distances, it dominates the large-scale structure of the universe. It's a paradox, a force so weak that we barely notice it in our daily lives, yet so powerful that it shapes the fate of galaxies. This contrast is at the heart of gravity's mystery. How can something so subtle be so essential? How can a force that we take for granted be the key to understanding the universe? These are questions that continue to drive scientific inquiry, and they remind us that even the most familiar aspects of reality can hold the deepest secrets. Let's shift our focus to the human experience. How our relationship with gravity has shaped not just our bodies, but our civilizations, our cultures, and even our imaginations. Gravity is so fundamental, so ever-present, that we rarely stop to think about it. Yet, it's the silent partner in every step we take, every structure we build, every leap of athleticism or act of creativity. If gravity were to vanish, it wouldn't just be a physical catastrophe, it would be a cultural and psychological earthquake, shaking the very foundations of what it means to be human. Consider architecture. Every building, from the humblest hut to the tallest skyscraper, is a response to gravity. The arches of Roman aqueducts, the flying buttresses of Gothic cathedrals, the steel skeletons of modern towers, all are designed to resist gravity's pull, to channel its force safely to the ground. Without gravity, the entire logic of construction collapses. There would be no need for foundations, no reason to build up rather than out or around. The very concept of a floor or a roof would become meaningless. Our cities, our homes, our monuments, all would lose their purpose and coherence. Think about sports. Every game, every contest is shaped by gravity. Basketballs arc through the air, soccer balls curve and dip, gymnasts flip and twist, all in a dance with gravity. The thrill of a slam dunk, the elegance of a high jump, the drama of a diving catch, these moments are possible only because of the constant, predictable pull of the Earth. In a world without gravity, sports as we know them would vanish. There would be no running, no jumping, no falling. Movement would become a matter of pushing off surfaces, drifting and colliding. The joy of flight would be replaced by the confusion of perpetual floating. Even our language is steeped in gravity. We talk about falling in love, rising to the occasion, feeling weighed down, or being uplifted. Gravity is a metaphor for seriousness, for importance, for the forces that shape our lives. Its absence would leave a void not just in our physical world, but in our stories, our songs, our sense of meaning. But perhaps the most profound impact would be on our sense of self. Gravity gives us orientation. It tells us which way is up, which way is down. It grounds us literally and figuratively. In its absence, we would lose our bearings, not just physically, but psychologically. Studies of astronauts in microgravity have shown that prolonged weightlessness can lead to disorientation, anxiety, even depression. The body loses muscle and bone, but the mind also struggles to adapt. In a world without gravity, these effects would be universal and inescapable. And yet, humans are nothing if not adaptable. Throughout history, we have faced challenges and found ways to overcome them. If gravity were to disappear, we would try to make sense of the new reality. We might invent new technologies, magnetic boots, tethered walkways, floating habitats. We might develop new forms of art, new games, new ways of moving and interacting. Our creativity would be tested as never before. But adaptation has its limits. The loss of gravity would quickly make the planet uninhabitable, as we've already seen. The atmosphere would escape, the oceans would drift away, the Earth itself would come apart. No amount of ingenuity could save us from the fundamental unraveling of the world. It's a sobering thought, a reminder of how much we depend on forces we cannot control or even fully understand. Let's contrast this with the experience of astronauts. In the microgravity of space, they float effortlessly, performing somersaults and gliding through the air. It looks fun, even liberating. But microgravity is not the same as zero gravity. The International Space Station, for example, is actually in freefall around the Earth, constantly falling but never hitting the ground. Gravity is still at work, shaping the station's orbit, keeping it tethered to the planet. The sensation of weightlessness is an illusion, a byproduct of perpetual motion. True zero gravity, the complete absence of gravitational force, has never been experienced by any human. If it were, the consequences would be far more severe than anything seen in space. This distinction is crucial. Microgravity can be managed, adapted to, even enjoyed. Zero gravity, on the other hand, would be catastrophic. The difference is not just a matter of degree, but of kind. It's the difference between a world that challenges us and a world that destroys us. And yet, the idea of escaping gravity has always fascinated us. From the myth of Icarus to the dreams of space travel, we have long imagined what it would be like to break free from the Earth's pull. Rockets, airplanes, even trampolines are all expressions of this desire. But every leap, every flight is ultimately a return to gravity. We can defy it for a moment, but we can never escape it entirely. This longing to transcend gravity is part of what makes us human. It drives our curiosity, our ambition, our willingness to explore the unknown. But it also reminds us of our limits, our dependence on the forces that shape our world. Gravity is both a constraint and a source of wonder, a challenge to be met, but also a gift to be cherished. So what if gravity suddenly turned off? The answer is both simple and profound. Everything would change. The world would become unrecognizable, life would become impossible, and the universe itself would unravel. But in imagining this scenario, we gain a deeper appreciation for the force that holds us together. We see, perhaps for the first time, just how miraculous our existence really is. As you float through this thought experiment, remember that gravity is not just a physical force. It's a thread that runs through every aspect of our lives, binding us to the Earth, to each other, and to the cosmos. Its absence would be a disaster, but its presence is a source of endless fascination and awe. If you followed this journey from the first floating pillow to the cosmic unraveling of galaxies, you might be feeling a mix of awe and unease. That's the power of a thought experiment. It lets us step outside the ordinary, to see the familiar with new eyes. Gravity, so often ignored or cursed when we stumble, is revealed as the silent architect of everything we know. Its sudden absence would not just be a disaster, it would be the end of the story, the closing of the book on life, structure, and meaning. But perhaps the most important lesson from this wild scenario is not about fear, but about gratitude. We live in a universe where gravity works, quietly and relentlessly, shaping the dance of planets and the beating of hearts. It is the reason the oceans stay in their basins, the air hugs the ground, and the stars gather in galaxies. It is the reason you can stand, walk, run, and even dream of flying. Gravity is the invisible hand that writes the script of existence, and its constancy is a gift beyond measure. This realization invites us to look at our world with fresh appreciation. The next time you watch a child leap into the air, or see a bird soar, or feel the reassuring weight of your own body, remember that you are participating in a cosmic miracle. The force that holds you to the ground is the same force that binds the universe together. It is both intimate and infinite, both ordinary and extraordinary. And yet, gravity is not the end of the story. It is a chapter in the ongoing quest to understand the universe. Scientists continue to probe its mysteries, searching for the elusive graviton, exploring the possibility of extra dimensions, and testing the limits of Einstein's theories. Each discovery brings new questions, new challenges, and new wonders. Gravity, it seems, is not just a force, but an invitation to curiosity, to exploration, to awe. So what if gravity suddenly turned off? The world would end, yes. But in imagining that end, we come to see the beauty of the world we have. We see the elegance of the laws that govern it, the fragility of the balance that sustains it, and the profound interconnectedness of all things. We see, in short, that gravity is not just a fact of life, but a reason to marvel. As you return to your day, feet firmly planted on the ground, take a moment to thank gravity. It is the reason you are here, the reason you can wonder, and the reason you can believe in the possibility of understanding the universe. And that perhaps is the greatest miracle of all.